Hi everyone, welcome to the class. In this new chapter, we will learn sequences in the series. Today we will learn sequences. What is a sequence? Mathematically, a sequence is defined as a function whose domain is a set of positive integers. Although a sequence is a function, it is common to represent sequences by subscript notation rather than by the standard function notation. For example, 1 is mapped onto a sub 1. What does that mean? Which means when x equals 1, f of 1 equals a sub 1. Use a sub 1 to represent f of 1. 2 is mapped onto a sub 2. 3 is mapped onto a sub 3. 4 is mapped onto a sub 4, and so on. N is mapped onto a sub n. So we also can write this as a sub 1, a sub 2, a sub 3, and so on, a sub n. These numbers are the terms, and these numbers are the terms of the sequence. And then the number a sub n is the nth term of the sequence. Okay, so this the subscript tells us which term in the sequence we are referring to. Okay, this is subscript a sub 1, a sub 2, a sub 1, which means the first term of the sequence, a sub 2 is the second term of the sequence. Okay, so example 1, writing the terms of the following sequences. Number A, letter A. The sequence is a sub n equals 2 plus nth power of negative 1. How much is a sub 1? Which means when x equals 1, how much the value of the function of the f of 1. So now we use a sub 1 to represent f of 1. A sub 1 equals 2 plus the negative 1 to the nth power. So now n is 1, first power. So negative 2 to the first power is negative 1. Negative 1 to the first power is negative 1 itself, right? So 2 plus negative 1 equals 1. So a sub 2 is 2 plus raise negative 1 to the second power. So that second power of negative 1 is positive 1. So positive 1 plus 2 equals 3. A sub 3 equals 2 plus negative 1 to the third power. How much is negative 1 to the third power? Yes, is negative 1. So 2 plus negative 1 is positive 1. A sub 4, 2 plus negative 1 to the fourth power equals 3. Yes. So then a sub 5, we know, is a 2 plus negative 1 raised to the fifth power, because the fifth is an odd number, right? Odd number. The fifth power to negative 1 is negative 1. So equals 1. So the a sub 6, yes, equals 3 again. So then, a sub 7 equals 1, back to 1. A sub of 8 equals 3. So all the odd terms, the value of the odd terms is 1. The value of the even terms equals 3. Let's see the second example. Bn, sequences Bn is a 1 over 2 to the nth power. B1 equals B1 equals first power to 1 second. So equals 1 second, 1/2. B2 equals 1 over 2 to the second power. So equals 1 over 4. right? And B3 equals 1 over 2 to the third power equals 1 over 8. Okay, how much is the B sub 4? Yes. B sub 4 equals 1 over 16. Okay. So B fifth equals 1 over 32. Okay, so observe these sequences. What's the difference between the B1, B2, B3, B4? So this is a sequence we also can write as 1/2, 1/4, 1/8, right? And 1 over 16, 1 over 32, and so on, 1 over 2 to the nth. So this is a sequence. You will find the B2 divided by B sub 2 divided by B sub 1 equals 1/2. B sub 3 divided by B sub 2 equals 1/2, right? So basically, the consecutive two terms, the quotient of B n over 1, B sub n over n plus 1 divided by B sub n equals 1/2. This type of sequence, we have the name for them. This type of sequence we call the geometric sequence. So the geometric sequence is a sequence that has a pattern of multiplying by a constant to determine consecutive terms. Namely, it has a common ratio R. The common ratio R in this case is 1/2. So basically, the second term of the sequence equals the first term times 1/2. The third term of the sequence equals 1/2 times the second term. Okay, we call this kind of the sequence we call the geometric sequence. So now I want you to click pause here to practice this one on your own. The sequence C sub n equals 2n. So 2n we call it as a general term. It's a 2n. You can also see the formula. Okay, so the formula of this sequence 2n. Click pause and solve it on your own, and observe each term. What's the difference between each terms? Okay, welcome back. So how much is C sub 1? C sub 1 equals 2 times 1 equals 2. Good. C sub 2 equals 2 times 2 is 4. Yes. C sub 3 equals 2 times 3 equals 6. C sub 4 equals 2 times 4 is 8. Okay, so now observe this C sub 1, C sub 2, C sub 3, C sub 4, which means the first term of the sequence, second term of the sequence, third term of the sequence, and the fourth term of the sequence. The first term of the sequence equals 2. The second term of the sequence, 4. The third term, 6. The fourth term, 8. Of course, the fifth term is 10 because 2 times 5 is 10. Okay, so what can we find? Yes, we find actually the second term equals the first term plus 2. The third term equals the second term plus 2. The fourth term equals the third term plus 2, right? So we also have the name. We also have the name for this type of the sequence. We call the arithmetic sequence. So an arithmetic sequence is a sequence that has a pattern of an ending of adding the same value to determine consecutive terms. It has a common difference D. The common difference D. The D equals A sub n plus 1 minus A sub n. So this type of the sequence, the name is, we called arithmetic sequence. So there's a common difference D between two consecutive terms of the sequence. And the sequence B, actually, we call it the geometric sequence. They have the common ratio R equals consecutive terms. Okay. Practice D and E. D and E. Click pause, practice on your own. At least list the four terms of the sequence. And then when I come back, let's check the answer together. D sub 1 equals 1 over 2 to the first power minus 1. So equals 1 over 1 equals 1, right? D sub 2 equals 2 to the second power. 2 to the second power n equals 2 minus 1. So the top is 4, denominator 3. And D sub 3 equals 3 to the second power. Denominator 2 to the third minus 1. So the top is 9, the bottom is 7. Right? D sub 4 equals 4 to the second power and 2 to the fourth power minus 1. 2 to the fourth, how much 2 to the fourth? 16. Minus 1, 15 in the denominator, right? And then top 4 times 4 is 16. Okay, then you can solve more. D sub 5, how much is D sub 5? The numerator 25. The denominator is 32 minus 1 is 31. Okay, and so on, so on. Okay, how about E? E sub 1, how much E sub 1? E sub 1 equals 1 over 2 minus 3 times 1. So it's negative 1. E sub 1. E sub 2 equals 2 on the numerator, 2 minus 3 times 2. So 2 in the numerator, 2 minus 6 is negative 4. So it's negative 1/2. E sub 3 equals 3 over 2 minus 3 times 3. 2 minus 3 times 3, 2 minus 9 is negative 7. So it's negative 3 over 7. E sub 4 equals 4 in the numerator, denominator 2 minus 3 times 4 equals 4 over 2 minus 12 is negative 4 over 10. Double check. Negative 10. Okay, so then simplify negative 2 over 5. Okay. So now, example 2 is giving you some terms of a sequence and ask you to write the formula for the nth term of a sequence. For example, A, 1, 1/2, 1/3, 1/4, 1 over 5. Yeah, this is easy, right? So this you can write as A sub n equals nth term. You only need to write nth term. You don't have to write the sequence. So based on the observation, A sub n equals 1 over n. That's easy. Okay, how about B? How about B? negative 1/2, 2/3. The first term is negative, the second positive, the third term negative, the fourth term positive again. Okay, so then you think about there's a negative 1 there to the nth power. You can write negative 1 to the nth power, because when n equals odd number, so then it's a negative 1. So that the first term, third term, fifth term, or negative. So then observe the fraction. What on the numerator? 1, 2, 3, 4, 5. It seems like n on the numerator. So what the denominator? 2, 3, 4, 5, 6. So it's a 1 more than the numerator. So here's the nth term. Negative 1 to the nth power times n over n plus 1.